greatest discoveries in science, and my presentation will be unique in that I'll be comparing two discoveries head to head, as opposed to covering a variety of topics. So my topic is light a wave or a particle? So you may be thinking, okay, so who discovered light? Well, as a child, all of us have wondered, where do all these colors come from? How come some things are brighter than others? Until Isaac Newton. He came up with the corpuscular theory of light, which basically said that corpuscles are light particles, and they went in a constant stream. This was a good enough explanation to explain reflection and refraction, but it was not satisfactory for other parts of light. So eventually, it was proven wrong, and scientists in the future tried to refine the theories. So at first, let's look at why light might be a wave. So based on intuition, you would think that, well, light is a wave since, well, you might think it's a beam, but obviously this cannot be true since these small lights fill up the entire room. So obviously it's going to have to spread out. You can observe this property of light at home, in your own house. So take your TV remote and turn it at a 45-degree angle to your television, and then try using it. It should still work. This is because light spreads out. So light as a wave. You might be thinking, okay, so if I drop a rock into a pool of water, it'll obviously produce waves. How is light similar to this? Well, light also has frequencies. Higher frequencies are usually close to the red end of the spectrum, and lower frequencies are close to the blue and ultraviolet side of the spectrum. As you can see here, this is an image of the Doppler effect. What this is basically, if something is moving away from you, the waves will be stretched. This can be observed when a police car is passing you. When it's coming towards you, the pitch increases, and when it moves away, it decreases. This is why stars seem redder when they're moving away from our planet. And also, we can observe the sharpness of shadows. If light is a particle, these shadows would be 100% sharp. It would be an exact shadow, basically. But they're not. They're blurry. Therefore, they have to be waves. Now let's talk about why light might be a particle. Most of us here know about photons, and this is the particle that is light. So obviously it has to be light, right? And these particles are massless and move at 299,792,458 meters per second. This is known as the universal speed limit, and nothing can pass it, and nothing with mass can reach it. But if something has negative mass, there's a possibility that it could exceed it, but that's totally theoretical for now. So now, there's also this idea of gravity, and even though photons are massless, they're still affected by gravity. Newtonian gravity says that it's affected by distance and mass, but we know now today that it's actually affected by energy and distance. Black holes have such an intense gravitational force that they actually completely pull light in. This is remarkable, and this is the reason why we can't see light. Later in this presentation, I will touch on one more interesting property of this gravitational force on light. Now, more evidence. Light can travel in a straight line. This is not possible for a wave, since it's a wave. It cannot travel straight, but light can. Also, waves require a medium to travel through. But light does not need a medium to travel through, since it can travel in a vacuum, and a vacuum has no matter at all. So the answer is it's both. This is known as wave-particle duality, and it's very special to light and photons. So it has properties. And you may be wondering, okay, if light travels straight, when there's no gravitational influence on it, how could it go like a wave? Because waves move up and down and have frequencies. Well, this frequency happens inside the photon itself, and it's based on the energy level of the photon. So why is this important to our everyday lives? Well, without the bouncing property of waves, light would eventually lose momentum, and it would never reach our eyes. Our world would be pitch dark, and we'd basically lose the sense. But without the properties of a particle, it wouldn't be able to move straight. And therefore, we would never reach, everything would just be a blur. And this helps us understand many things in quantum physics. For example, it helps us further differentiate waves and particles. Also, this helps us understand more concepts like the uncertainty principle. So in everyday life, how is light useful? Well, there are MRIs and X-rays, which basically are a very high frequency beam of light, which can penetrate our skin and look at our bones. There's also the microwave. This uses a very high frequency beam of light called microwaves, which heat up our food. Our television screens obviously use visible light, but they also use infrared to communicate with the remote. Radios use sound for us to hear, but how do you think they broadcast them? They literally use radio waves, and they're a very low wavelength beam of light. I enjoy playing with a lot of toys, and remote control toys are very fun to play with, and these also use radio waves. So this, I think a really important part about discoveries is fueling new discoveries. And some discoveries that were based off light were the photoelectric effect, which was discovered by Einstein, and the uncertainty principle, discovered by Heisenberg. So where are the discoveries? You may be wondering, this was a presentation about the greatest discoveries in science. So far I've only told you about light. Well, that's the beauty of it. Light alone is influenced by all these things and influences these things. So I think that in order to progress in the future, we have to learn from the past. And as Isaac Newton once said, if I've seen a little further than others, it is upon standing on the shoulders of giants. Thank you.
If you liked the video, press like, and if you want more like this, then subscribe. Here's the previous video in case you missed it, and if you want your friends and family to see this video, share it with them. Thanks for watching. Cram out.